I'm getting bored of my pet store, so let's vibe build an entire forum application in like 1 minute. We're going to call it forum. It's going to have 3 objects. This is the entire prompt I'm using. I'm just going to kind of cut it up into pieces so that we're sort of defining user, post, and comment. Let's say we want post to be like the main object. That's all. All right, so we got redirected here. There's not too much going on. We could change the name if we wanted. I would say the 2 main things we want to do is to think a little bit about the relationships that these objects are going to have and set some appropriate database keys. So I think for this one, we are probably going to want to find all of the posts that a user made. So I'm going to put poster ID as a secondary key. And then we're probably also going to want to find all the comments on a post and all of the comments by a specific user. That's the first one. So post ID is going to be that. We don't need too much else. Let's just make sure that we have our backend enabled and that we're going to check user authorization. That way, only people who I authorize can use this. That's all we need. All right, that's immediate. Let's go ahead and jump over to this. Yep, that looks pretty good. That's a post. I don't think we need a time. That could be optional. But like, let's go ahead and make a post from like the first user title or something. Could be like the first line. 1 line of text, another. Yeah. All right, and then the first time we make a request here, it's going to take a bit. It's just because it's setting up the actual databases that your backend application is going to run on. It's really nothing to be concerned about. Just be aware. That worked with no problems. Let's go ahead and make another post. That way we can query by the same user ID and make sure that we get both of them. Let's say this post was like really popular though, and it had some like slightly different provocative content, you know. You can see that one happened much faster, like immediately. All right, so we want to go ahead and query by the poster ID, right? So let's go ahead and stick that in our query parameters. You can see there's already a few there. That's kind of just to keep you from like accidentally downloading your entire database at once. But yeah, we can go ahead and pull posts in at once. You can see it works totally fine. We have complete object persistence here. There is a real database behind all this. Maybe when we want to change the first post, maybe we decided that it actually wasn't that good after all. Like, it doesn't get that many votes. We can update that. That's pretty easy. That happens immediately. We can also query by like a specific ID. It'll reload the page, pulling it in from the database again. Everything's really seamless. Just kind of works. You can delete the post. Doesn't matter. That works too. Let's go ahead and pull in all the posts again. You can see that we only have the original one left. So persistence is one important feature, but how do we handle referential integrity? So by default, with no configurations, this is actually how you're going to get. You're not going to have a normalized database where comments could be reused across posts. I do think that this makes sense for the post comment use case in which a comment is not going to be shared across multiple posts. But what if you wanted it to be, or what if you wanted to, again, do those specific lookups that we were considering, like searching all comments by a post ID? Our API does actually support that, right? So, in my database right now, I have a couple posts or a couple comments in a separate comment table that have the same post ID, 16. So we can just go ahead and get those out if we want to, practice real quick. Just select the list endpoint for comments, and 16 post ID is the query parameter. That's really all we need to make it work. So if we get that, then you can see we've got the correct content that is being loaded in from the database, right? But how would you actually create this data, right? This comment data. So a couple ways. You could just post it like this, and it'll go to the forum posts, and then comment is the table that's going to go to if you post it. So you can create new comments that way with a post ID, and that's fine. But again, we want to actually modify the structure of how the API works, perhaps, so that we could set up something like this, posts with multiple comments, and then get the behavior that when we post to this forum post endpoint, it will actually maybe create the parent first, and then create the comments that have a back reference through post ID to that parent, right? So it'll post the post. Sorry for the redundant naming. Post the post, we get a response that has an ID in it because we sent one. And then if you do not provide an ID field, it'll actually create an ID field for you called UUID v4. But since this schema has one, it's going to use ID. Then when we create our comments, it'll be injected into the post ID field. So that all sounds really wonderful. How do we get that actually accomplished? We got to edit our schema, right? So go to the parent, the post in this case, where we actually have the reference to comment.json. And we get in here, we're going to add child ref to parent and API creation strategy. So this one's an optional field for using it this way, but since we want to inject that post ID variable in the child, we're going to set that. And yeah, parent first body ID is the strategy that we're going to want to do for that. So when we have this configuration, every time we submit an API endpoint with a post here, it's actually going to create 3 separate requests. It's going to create a normalized database object of just this details without actually adding any comments to the post object. There won't be any comments in the post object anymore. It'll just do these details. Then it will create this comment that has the post ID, and then it'll create the next comment that also has the post ID. And yeah, you'll get 201 created 3 separate times for each of those API calls, which is pretty convenient. I want to mention some exciting new features we've been working on. So this is the display page. You can see here that you can edit it with Blockforger normally, and it will actually redirect you to Blockforger. No problems with that. And you can see we've retrieved both the post and the comments that are attached to it. This is just a table format essentially, and it's good for read-only purposes essentially. If you need to send someone just a view of like what the data looks like, what's going on, and they're maybe a non-technical user or they aren't onboarded to Blockforger's methodologies yet, this is just a good format for them to see data in. It's optimized for reads, like I said, and then you can still use Blockforger to make writes. So if you wanted to, modify this data with like a put or patch request, you would click this link and do that. Some other features to talk about, we've got API keys. This enables our event bridge integration, but you can also send synchronous API calls with the API key for programmatic access. And then the event bridge integration allows you to do a lot of asynchronous writes to our same databases and stuff in DynamoDB. But you are actually also able to receive events from EventBridge, and you can use this to notify metrics, alerting, really anything like that when your API gets interacted with. In addition to the metrics and alerting use case, enables some interesting business logic workflows where you're using the document store of Blockforger, but as your business grows, you have the flexibility to implement new business logic in your own server that lives between the Blockforger backend and the Blockforger frontend. We think that that's really cool, so we're happy to support it.